This video will focus on network analysis and ArcGIS Network Analyst. Now, working with Network Analyst, you're going to see that the theory behind it obviously is going to be in tandem with the operations. So let's just look at some of the things that are a part of it. For starters, physical lines. Well, obviously, I'm sure you've already surmised that with network analysis, utilizing the Arc Network Analyst extension, that a linear network of some kind is going to be analyzed. Now, it doesn't have to be just roads. It could be, as you see in the example here, rivers or power lines. So you've got some kind of a linear feature that you're going to be in some way analyzing the connectivity and the movement. But also along the way, you're going to be developing, how should we say, another layer of information. Virtual lines that it's going to be a method for the software to determine the connectivity. So new data is going to be generated along the way, and that new data is going to look a lot like the physical lines. So, looking at linear spatial analysis, the two major things are, number one, the structure of connection, which we're going to get into very, very shortly, and number two, movement within the system. It isn't just simply connecting the dots, so to speak, no pun intended. It's also about the internal behavior that you're trying to model. An example for that would be, do you have streets that are one-way or two-way? That would be an example of movement within the system. Looking at a power grid, looking at the amount of energy that could be transferred within certain areas versus others. That could be considered movement in the system also. Okay, so how are we going to look at connectivity? Well, pretty much this. The more connection you have, the better. And quite often that is determined by what you see here, C matrices. And it's really just looking at, how many options do you have in your network from going from one location to another? How complex is it? And along the way, you're going to find that a structure called nodes are rather important. Looking at places where linear features interconnect. So again, the generation of new data that's going to look a lot like that linear feature that you're using for your analysis, but it's going to start identifying the amount of connectivity that's there. And you'll see that once you start working with Network Analyst, it's going to be pretty well evident. So now my guess is this, that just about everybody watching this video at some point utilize some kind of a mobile device or your computer to determine the path between where you are and where you want to go on a trip. That's gosh, it's so commonplace. I'm sure that some of you are like asking, where did this guy come from? This has been around for a long time. Well, from the time this video was made, there was just if you go back a couple of years, it wasn't really that long ago that this was kind of like new stuff. But okay, now you're hearing the age of the narrator here. Well, how does it all work? Let's look at the minimum spanning tree criteria. A minimum spanning tree is just trying to figure out how do you get from point A to point B. Well, for starter, number of links is one less than number of nodes. So here again, we're bringing up these nodes again. You're going to see that just the way it works out mathematically, that when you look at the number of links versus the total number of those points of connectivity, that you're going to have one less. Number two, root of the tree is located at one node. Okay, where are you taking off from? Okay, that's the root of the tree. Number three, the distance between each node and the root are minimized. When you're looking at the point of origin and the place you want to go, it's actually, this is going to dovetail right into point number 4, determines least network cost between nodes. what it's doing is this: it's simply adding up. It's saying, okay, if you're looking at distance, okay, if you once it starts running its operations and said between here and there, going down these certain roads, this is the shortest distance. There, that is the cost the distance was. However, though, if it was something like dealing with speed limits, saying, by the way, even though this road is longer, you can go drive a lot faster. It does its calculation. Okay, well, when it's looking at cost, it's looking at, say, it's adding in also the speed that you're allowed to drive on a certain road. So, looking at the math behind this, may I introduce you to the shortest path algorithm. And I'm sure that a lot of you know what algorithms are, but if you are being introduced to this, we have a nice definition here on this slide. And so the computer is running a series of mathematical calculation towards an objective. Now, with the shortest path algorithm, it's just simply asking, I'm sorry, that's so human of me. It is calculating what is, looking at all the linkages, what is the least cost between point A to point B, and it's running all of them really for the most part until it says, hey, this one right here seems like it is the path of least cost, of distance or time or a combination of the two. And as you see in point number 3, either the criteria of success is met or it fails. If it runs one pathway and that pathway has a nice low value for the cost, and then it runs another pathway and that second pathway is a little bit higher in value, well, it dumps it. Okay, it didn't meet the criteria of beating the lower value that was already calculated through linkages. So, using ArcGIS Network Analyst, what kind of problems are we going to start solving when it comes to networking? The shortest path problem is the simplest of them all. Okay, you've got a point of origin and a destination. Find the shortest route, and we've been kind of discussing that already for the past couple of minutes. So that's number one. But can we make this a little bit more complex, though? Yes, we can. The second level of complexity, the traveling salesman problem, it's identified as such because that traveling salesman is going to want to visit all of his or her clients and sell products. And so the question is this: how can that salesperson, as they drive around the countryside, what is the shortest path that they can take in order for them to reach all of their customers and save well, at least consume the least amount of fuel? Now, it doesn't have to be, of course, selling, whatever product. It's just simply saying, hey, there's going to be several stops along the way, and what is the pathway of least cost? Now, for transportation problem. Here, let me read this verbatim. Find a pattern of shipments of goods from a number of factories to a number of outlets, which will minimize total shipping cost. Here, let me simplify that. I don't know about you, but I am a connoisseur of pizza. I have been a connoisseur since I was a little kid, and I'll probably have one slice of pizza in my mouth the day I die. So, when it comes to pizza places dishing out services to the area, if you had several different locations in an area, and somebody calls up and says, hey, we would like to get some pizza, the question is, which pizza delivery service or which store would be the one that would be most efficient in transporting the goods to the customer? Now, another kind of network analyst task: traffic assignment problems. Given the number of trips to be made between origins and destinations, predict how traffic will allocate itself to a network. And the example, of course, of how many vehicles will use each route is there. It's talking about the behavior within the system. Now you're starting to add in the nuances of a network. And since we're also probably well versed in traffic, well, think about it when it comes to all the things that you have to deal with, barriers, construction that will slow you down, areas, of course, that are highways, so you can, like for instance, in a lot of major cities, even though you're on the highway and you're technically driving a longer distance, you get from point A to point B faster because you're traveling much faster. and also, well, detours and things like that. And then finally, you could do some analysis, identify the number of vehicles that were transported within the system. And by the way, another thing too to consider is even terrain. As you're driving around, like for here in well, the narrator now lives in Kansas as he's making this video. The neighboring state, Colorado, beautiful state. As you're driving along, and you're not burning off too much gas when you're in the plains area, and then after a while you're in the mountains, and you might travel half the distance in the mountains and burn much more fuel than you would if you're out in an open plain area. So there's another thing that you can add into the modeling of the network. Okay, so what does Network Analyst look like? Well, the first image that's being shared here looks a lot like something you would find off of a lot of internet sites or apps. And so yes, there is a lot of similarity there. And here, when it came to the traveling salesman approach, you had to stop at several different locations, and you'll see that the directions are provided. So yes, Spatial Analyst can actually do that for you, and you could do a lot more though beyond that. Now, in line with the theory of the transportation problem, here you see several fire stations that well, the call came out at 1202 Twin Peaks Boulevard, and it's time to figure out just who would have been the station that would have been the fastest to get there, or if one of those stations was already committed, what other stations still were within the zone of acceptable response time for a fire call. Now, sort of another way of looking at the transportation problem, here you see warehouses within a city in the world. I'll let you just guess which city that is, looking at the patterns there. But you've got a warehouse that is taking care of a region, and there are a lot of industries out there. Like, for instance, a lot of those online services that you could go on there and get books and whatever electronic equipment and so on and so forth. Sorry, I'm not going to say the name of that service, but I've driven around in the U.S. and I've actually seen their major warehouses. They're gigantic. So what they do is they service a large area. Using Network Analyst, you could identify the zones that a warehouse could service stores within a region. So what does Spatial Analyst look like in the interface of ArcMap? Well, there's always the view, and you see over to the right that it looks like there's a traveling salesman situation that was analyzed, and you have the route calculated. But now more towards the middle, you're going to see that there is a dialog box that's opened up for a Network Analyst, where you see route at the top, and then you see point 1, point 2, point 3. Well, you're going to get that additional interface added into the environment. But looking further into the view here, over to the far left, in what we call a table of contents still, you see that wow, they got all these new icons here. It says stops, located, unlocated, error, time violations, and things like that. Don't be scared off by all the new bells and whistles that you're going to be working with. A lot of them, for the most part, you're not going to have to deal with. They're there in case, let's say you had a really complex network, back to that modeling of a city that had the detours and the one-way, two-way streets and speed limits and so on and so forth. Well, that's where you'll see a lot of these icons, they have their place. And, well, if there was a barrier that was out on the landscape, say there was some kind of natural incident, like, for instance, there was some flooding, and certain roads were no longer accessible. Well, you could actually create a barrier icon. So the bottom line is this: there's a lot of different flavors now when it comes to the icons that you can see within the interface to help describe just what's happening. So just to conclude, Network Analyst is a very pragmatic extension. A lot of people maybe don't know maybe not ArcMap directly, but software systems that they seem to be doing things in at least the results are similar. The objectives, finding the store, the quickest way to a store in the landscape, getting an ambulance quickly from point A to point B, all those sorts of things that we've taken for granted now that are at our fingertips. You're going to see that ArcMap, ESRI software, really they had a real big role to play in this this revolution. They truly did. And Network Analyst can be a very, very useful extension used in various ways. Thank you.